Okay, there we go. So, section 4.2, like I said, there's only 10 questions on this worksheet, but I'll probably give you another worksheet, probably on Monday. So, let's do this. Let's do the odds, see how long that takes us. Then we'll probably back up and hit the evens too. I think there'll be enough time to get through all 10 of these things here. So, solving exponential, remember, in case you forgot what an exponential function is, exponential function means your exponent has a variable and exponent has x. Like, for example, if I gave you 3 to the power of x, that's exponential. 5 to the power of x minus 2, that's exponential. X to the power of 7, that is not exponential, okay? If it was 7 to the x, it would be exponential, okay? So if your exponent has a variable in it, it's exponential. So when you look at the very first question on 4-2, they give us 7 to the x plus 6 equals 7 to the 3x minus 4. Not that you would do it in Algebra 1, but this is basically an Algebra 1 problem. If the bases are the same, and they are, they're both 7, the exponents have to be the same. So we can basically take those 7s and just wipe them out and solve x plus 6 equals 3x minus 4. That's all you got to do. Okay? So we do that. We solve, subtract x from each side. 6 equals 2x minus 4. Add 4 to each side. 6 and 4 is 10 equals 2x divided by 2. X is 10 divided by 2, which is 5. So like I said, you wouldn't do one like this. You would never see something like this in Algebra 1 class, but once you get past that very first step, it's just Algebra 1. That's all it is, solving an equation with x on each side. So hopefully that one's not too difficult. Number 3, this would be more like an Algebra 2 question, maybe Algebra 1. Again, you wouldn't see one like this in Algebra 1 or Algebra 2 the way it's written. But you have 3 to the 2x plus 3 equals 3 to the x squared. Okay? So it starts out the same. Your bases are the same, so you can basically just ignore them. We just ignore those 3. So I'm going to write down 2x plus 3 equals x squared. Okay? Let's go back to Algebra 2. What do we do now? You guys remember what we do now? What's that?
We're talking about the side.
Oh, yeah, I thought I heard something. I was wondering what that was. Any idea what we're going to do? How are we going to solve that thing? Why?
Because then we can factor.
We have to make it equal 0? We didn't make this one equal 0. Do we have to?
Yeah.
Why? You're right, why?
There's an x2.
So quadrate, second degree, gotta equal 0. It's gotta equal 0. So I'm gonna, it'd be quicker to minus the x squared, but I don't want that to be negative. I'm gonna subtract 2x and subtract 3. So we do that, we have 0 equals x squared minus 2x minus 3. Okay? Equals 0, that's a good thing. Now what? Factor, 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 factor. 0 equals, draw 2 sets of parentheses, x squared is x and x. Last term's negative, so plus and minus. Times to negative 3, add to negative 2, negative 3, and positive 1. So it looks like our two answers are negative 1 and positive 3. And they are. Negative 1 and positive 3. That wasn't too bad. Now when they get to number 5, now it looks like it'll go a little bit tougher. A little bit tougher. You got to do a little more thinking when you get to number 5. Okay, so number 5, we have what? 2 to the negative 100x power equals 0.5 to the x minus 4. It looks a little tougher because the bases are not the same. So you need to make them the same. Okay? So we have a 2 right here and we have a 0.5 right there. I want to rewrite them so they have the same base. And this is so easy, and I don't mean to minimize and make you guys feel bad here, okay? But this is really kind of like a 4th or 5th grade question, maybe 6th grade question, okay? I see 0.5, and I see a 2 over there. Now, we're not going to make them the same yet, but we can get them a little bit closer. When you see 0.5, I mean, is there another way I could write 0.5? Why do you think that's a good idea? What's 1/2 got in it? Huh? It does have a 1, but it has a 2. And we see a 2 over here. You're right, it does have a 1, but it's the 2 we really want, okay? So 2 to the negative 100x equals 1/2 the x minus 4. Okay, that's better. It's not great, but it's better. That's definitely how I want to start it out. Okay. We don't normally do this. This 2 on bottom is 2 to the first power. I could move that 2 to the first power up, and you guys remember what happens when I move the 2 to the first power to the top? It changes somehow. You guys remember doing problems like this? If I give you 5 to the negative second power, everybody here, everybody, you guys included, you know that 5 squared is 25, so that when I taught you 5 to the negative second, everybody thought it was negative 25, and it's not negative 25. It's not. 5 to the negative second is the same as 1 over 5 to the second. So it's not negative 25, it's 1 over 25. So, if I have 5 to the negative second and I put it on bottom, it turns into 5 to the positive second. So what can I do if I have 2 to the first on bottom? I can put it on top and make it 2 to the what? Negative first. Normally we don't like negatives, exponents. Normally we don't, but if I do that, I don't really like negative exponents, but what's nice about this now? What's the same? Yeah, the bases, they're both 2. They're both 2. So what we did, we rewrote 0.5 as a half, and that's the same as 2 to the negative first power, okay? You might have forgotten this. Now, way back, I know you haven't forgotten this. X to the second times x to the third is x to the fifth. If I give you x to the second to the third, remember that's x to the sixth. When you times, you add. When you have a power to a power, you times, okay? So I could say 2 to the negative 100th, and what's 2 to the negative first to the x minus 4? 2 to the, what do I do with these powers?
X minus.
Did you forget to write that?
Yeah, the one from
Oh,
the,
yep. Thank you.
negative x plus 4.
Yeah, when you have a power to a power, you times them. Okay, we're getting there. Now what can we do? Cross out the bases, cross out the 2's. You don't need the 2's. So negative 100x equals negative x plus 4. The last question, Lotus said you got to have it equal 0. It's got to equal 0. Does this one have to equal 0? No. Can you make it equal 0? You can. You don't need to. I mean, if I gave you this question right here, 3x minus 1 equals 10. Could I subtract 10 to each side? Could I do that? Sure. Is it necessary? No. I mean, what do you want to do? What 2 steps do you want to do? First step, you want to do what? Add 1, then divide 3. It's not wrong. It's unnecessary. You don't need to have it equal 0. It's when it's a quadratic. When it's a power of 2, it has to equal 0. This is to the power of 1. So I'm going to add x to each side. Negative 100x and a positive 1x and negative 99x equals 4. Divide by negative 99, and the answer is 4 over negative 99. So negative 4/99. Number 7, getting harder yet. 4 to the x minus 3 equals 8 to the 4 minus x. Okay? So, our bases are not the same. I want to make them the same. And you don't need to make 4 into 8 or 8 into 4. You don't need to do that. You just need to make them the same. Okay? So, some students might go, well, I could do this. 8 is the same as 2 times 4. Well, then your base is 2 times 4. Your base here is just 4. Okay? Anyway, I mean, kind of think back. It's a little higher level than this, though. I said rewrite 0.5. You guys said it was a half. Okay? Can you think of another way of saying the number 4 or the number 8 using other numbers? Like, for example, 8, you could say like 7 plus 1. That's not what we want to do, though. We don't want 7 and 1. Okay? Can you think of a way that we could rewrite 4? Think of it as a base and a power. How can I rewrite 4 as a base and a power? How can I rewrite 8 as a base and a power?
2 squared, 4 squared.
Is that, you think that's a good idea?
Yeah.
Why? 2 words. Same base. Same base. Both 2. You don't need to make 4 into 8 or 8 into 4. We can make both 2's. So let's make it 2 squared to the x minus 3 equals 2 to the third, 4 minus x. I'm just curious. I mean, since you guys have had me 2, 3, 4 years, whatever it is. Do you think Kale likes this section or hates this section?
8.
Really? I love this section. This is my favorite. Oh, this is like right there with logarithms. I love this section. This is fun stuff. I love logarithms. This is fun. I love this section. Okay, so we have a power to a power. So we times them. So 2 to the 2x minus 6 equals 2 to the 12 minus 3x. Now Now it's easy. Take off the bases. Get rid of the bases. So 2x minus 6 equals 12 minus 3x. Add 3x to each side. 2 and 3 is 5x minus 6 is 12. Add 6. 5x is 12 plus 6, which is 18. Divided by 5, x is 18 fifths. Okay, number 9. Okay, so we have 4 to the x times 1/2 to the 3 minus 2x equals 8 times 2 to the x, oops, 2 to the x in parentheses, squared. Okay, so we got stuff all over the place. Make sure I wrote down right. 1/2, 3 to the 2 minus x, or 3 minus 2x, 8 times 2 to the x squared, okay? So we got all kinds of bases, and they're all different all over the place. Any idea what our bases are all gonna be? 2 to some power. Make them all 2 to some power. So 4 is the same as what? 2 squared to the x times, we've already done this right here, 1/2, that 2 is to the first power. Move that 2 to the first power up, it's what? 2 to the negative first, to the 3 minus 2x equals, can I rewrite 8? 2 to the third times 2 to the, when it's a power to a power, and be careful here, some students will go, well, 2 to the x to the second would be 2 to the x squared. Not 2 to the x squared, 2 to the 2x. When you have a power to a power, you don't do a power to a power, you time it. Okay? That looks a little better, but it's still kind of messy. Okay? 2 to the second to the 2x is 2 to the 2x times 2. We have a power to a power, we times them, so negative 3 plus 2x equals, when we times, we do what with our bases? As long as the bases, and they are. So, 2 to the, what's 3 plus 2x?
Just read.
3 plus 2x. You can't combine those. 3, if you take 3, many times you add 3 plus 2x is 3 plus 2x. Okay, it's getting better. It was a yucky mess, it's getting there though. Same thing over here, we're timesing and our bases are the same. So write it as one base. So 2 to the,
-6.
careful, no, when you times you add.
-1
No, come on. Yes, you do, you're gonna kick yourself in about 2 seconds. Add these up, add your like terms. You're still up, Luke, nope, you ain't punting here. Add your like terms, what are you gonna combine with 2x?
2x.
And get, there you go, 4x and what else? There you go. Now we can get rid of our bases. So 4x minus 3 is 3 plus 2x. Subtract 2x to each side. 2x minus 3 equals 3. Man, all this mess is going to come out as a nice number. 2x is 3 plus 3, which is 6, divided by 2. X is 6 divided by 2, which is 3. How about we'll do that? Well, let's do this. It'll be nice. Since Meerkat's not here and Alexis is working with Stacy, we'll go over these other ones on Monday. But this ain't the end of the worksheet. This is the end of this worksheet. I'm going to give you a new worksheet also. We'll do these 5 questions we skipped on Monday, and I'm also going to start a new worksheet with you guys. Same section. It's just same type of props. Just there just wasn't enough problems in here. So, all right. Homework quiz time.